All right, class, this is part 2 of our lesson 3.7 on problem solving strategies. So let's get, I'm going to actually start this from the beginning of this lesson, 3.7. So we have a town population, and it's got a growing population that's growing linearly. In 2018, the population was 42,000 people. The population has been growing by 1,500 people per year. Now, they're asking us to write an equation and answer a question about the population. So there's two things here. But there's a third thing that I want you to do as well. I want you to graph what's going on. Now, theoretically, in this lesson, we're learning that the words can be turned into equations, and the words can be turned into graphs, and we can use the graph or the equation to solve it. And I kind of want you to be able to do all three. Turn the words into an equation, turn the equation and the words into a graph, and then connect the graph to the equation and help you see all the connections. And that's what I want to do on this problem. Now, thinking ahead about graphing, before we can go anywhere with the equation or the graph, we have to figure out variables. And there's a couple of things that are changing here. The years are changing, and the population is changing. So it's up to us to figure out which one is X and which one is Y. And so it turns out the number in the population depends on which year it is. So we have to know the year so we can figure out the population. Now this idea of depends is your y variable. And that would make X equal to the Y would be the population, X would be the year. Okay, so I had to think that out here. So we would have the x-axis down here be years and the y-axis be population. However, I'm going to do this with a little bit more context. I'm going to call t equaling the years. Now, we still need to add something there. P is the population. Okay, so on my graph over here then, that makes this y-axis the p numbers, and this makes the x-axis the years. Now this isn't quite complete yet. We're going to add something to it. And as we start graphing, we have to think about what does this mean. My x numbers, I've got the beginning of the origin, I've got one box, two boxes. And what is the interpretation of this? If I leave it like it is right now, this would be year 0. What is year 0? Well, that's when Jesus was born. J-E-S. That's a long ways back. And it's also a long ways away from 2018. So that means we need to have 2018, actually all the way up to 2023 boxes on our grid. That is not realistic to graph with our x-axis having 2025 grid points. No, not practical. What we need to do is reinterpret. We're going to do a trick here. It's a word trick, but it makes the whole thing way easier to graph. It turns out it also makes the equation easy to work as well. We're going to interpret this as 0 is my starting year, and my starting year is 2018. Now, how do we say that then? So this is the t-axis. And so we're going to say t is not years. Let's come over here and define it better. T is years after 2018. So those two extra words really changed the story for us a lot. So if we think about t as years after, and then we go t equals 1, well, if t equals 1, what does that mean? 1 year after 2018. Well, that's 2019. What does t equal 2 mean? T is 2, that's 2 years after 2018. So that means we're at 2020. And this way we get to use easy numbers when we count on the x-axis. So it's not actually the x-axis, it's the t-axis. And so the t is years after 2018. That little trick does a lot to help with the graph and with the algebra equation. Okay, now let's go back to the interpretation. So we're trying to understand the problem, and that means explaining variables, which variables we're going to use. So this is like my output, my y's. Oops. These are like my y's. I'm not really going to use y's, and these are like my x's, but I'm not going to use x's. I'm going to use t and p. Okay, so if I did that, it would be, if we know m times time plus the b, the y-intercept number, we could get our equation. And we do have a few more pieces of information. We have a pair here, the year and the population. But in 2018, the time is 0 because we haven't gone past 2018 yet. And the population is 42,000. Well, that makes a point. That makes the point 0, 42,000. So this would be my B number. We also have each year. There's that each year thing. So when we're doing each year, that means we have to multiply that population number by each year. So that's my M number right there. There's my slope, my rate of change, 1,500 people per year. So our equation is 1,500 times time plus 42,000. So we wrote the equation. Now, we have a choice to solve this with algebra, and we should. But I also want to graph it so that you can see and interpret with the graphing as well. Okay, let's go ahead and finish off the algebra and solve the second part. We have a question here. So this is part 1 done. Part 2 now. And the year is, we want to find the year. Find the population for 2023. Okay, now I can't plug in 2023 because t is not 2023. We're not using that interpretation for time. We're using years after 2018. So how many years after 2018? Let's subtract. And that's 5. So t equals 5 years. Now I'm just going to say 5. T equals 5 because 2023 is 5 years after 2018. So this is what I'm going to plug in. So we'll be able to go P equals 1,500 times plus 42,000. And I'm going to plug in 5. Now, plug in the calculator, do the math, and we find out the population. Let's go back to black for that. The population equals 49,500 people. Now, T was 5. What year is this? It's 5 years after 2018. So the 5 represents years after 2018, which is in 2023. That's the answer to the algebra there. But I'd also like to explore this algebra equation graphically. How could we see this graphically? Okay, now we've already figured out the horizontal axis. T is time, years after 2018. So this part we have figured out. Now, what about the population? Well, the population only has 10 boxes. And we need to get 50,000 people on this graph here. So that is not going to be very easy to do with 10 boxes and get thousands and thousands of people on those 10 boxes. Okay, so I'm going to do something kind of tricky here. I'm going to rely on my starting point, 42,000, and my m number, which is 1,500. Now I'm going to turn it into rise over run by making it into a fraction, so I'm going to divide by 1. And I'm not going to worry about the y-axis. I'm just going to pick a starting point because I'm not going to be able to get, I could 50,000 at the top or something, but that would be really hard to figure out what's happening in between each one. This would have to be 45,000, and that's just too much change in one box. So we're going to do it slightly different. Just pick a random point. And let's call this 42,000. That's my starting point. Check. Now I want to draw a line because it says it's linearly growing. And I'm going to use the slope to draw my line. Okay, so I'm going to do a run of 1 year. Now I'm going to do a rise of, this is 1, and I'm going to call that 1,500. So that's my next dot. Now that means I was at 42,000 people and I added 1,500 people. So my first stair step took me up to 43,500. I'm going to do one more, run of 1, rise of 1,500. So that means from 43,500 I added 1,500. So now I'm up to 45,000. Okay, and I have a line. I'm going to draw a line here and connect the dots. All right, so we got our line. Now, how does the graph help us with our question? Recall from the problem that we wanted to find the population in 2023. And we figured out, okay, 2023 is 5 years after 2018. So that means t equals 5. And what the question is then is if we have an ordered pair 5, the population will be the y number or the second coordinate. And we can find that if we just go to the graph. We've got 3, 4, 5. We're going to use this, find the point on the graph. It's right up there. And it's going to be, this is the population number. All I need to do is figure out that number. So if we were to continue plotting, we would be able to calculate our way up here and realize, well, it is 1, 2, we went up 1, 2, 3 times, 4 times, 5 times. So if we do 5 times the slope number, that means taking the 1,500 times 5. So I mentioned that 5 times 1,500, so we're rising 1,500 each time, and we went up 5 years, so it's like 5 times. So that means 7,500 people were added to our starting year. So if we take that 7,500 and add it to the 42,000 people that we started with, we add it once, twice, 3, 4 times, we get all the way up here to 5 times increase, and that gives us a picture version of our solution. So we're seeing this problem analyzed graphically and seeing it analyzed algebraically. All right, so we've got 2 different ways, and I'd like you to be able to understand both ways. Now, sometimes the graphing is easier. Sometimes the algebra is easier. And I would say in this case, the algebra was easier to solve with. It was just less writing and less figuring. But it is important to see both ways. Okay, hope that was helpful. I'm going to give you another video it's a separate video on the last problem. So check that out as well.